Uh, Good evening and welcome. I think we can start. Just a second. Give me a second. Yeah. So Manushri M.
Sir, is my audio and video clear, sir?
Yes, clear. We can start.
Yes, sir.
Now tell me the name of your task.
Sir, you are not audible, sir.
Name of your task.
Predictive modeling, sir.
Okay. Share the screen.
Shall I start, sir?
Yes, yes.
Yes, sir.
Yeah, I have now the screen sharing.
Good evening, sir, and good evening, all the panel members. I'm Manushri from the Data Engineer Department of Hackveda. I'm present here to present my task, which is titled as Predictive Modeling using Student Performance Dataset. So throughout this session, we are going to have a look at all these points, the real meaning of predictive modeling, the dataset overview, the kind of dataset which I have taken in order to show my predictive modeling task, the different algorithms which I have taken in order to pick up the best algorithm which correlates best with this dataset, and then the point how I have deployed my algorithm in this dataset and the valuation and the validation of this model. Let us get into the task. So before getting into the dataset overview, what is predictive modeling? Why have we need to do the predictive modeling is, predictive modeling is nothing but the prediction of a future event. So for example, let me consider an example. Let us take weather forecast. Why there is a need for the people to predict the weather based on various factors like the wind, the clouds and all those things, because we need to know how the weather is going to be in the future in order for our future preparation of events in the future plan. So this is basically known as predictive modeling. We predict the future event of raining based on factors like wind, clouds, and etc. So basically, predictive modeling is termed as such like this, and this is one of the best examples to explain predictive modeling. So let us get into our task. So Hackveda provided me with this data set, which consists of all these features like gender, race, ethnicity, parental status, the lunch, the test preparation, max score, the reading score, and the writing score. So all these features within this given data set are the independent variables. So none of them here are dependent on one another. So this gender is not dependent on the race or the ethnicity, or this test preparation is or the lunch is not dependent on this race or ethnicity. So these are the independent variables where one variable is not dependent on the other variable, but this test preparation is dependent on the max score, reading score is dependent on the test preparation, max score, writing score, and all these are dependent on the test preparation. So these are all the gender, race, parental lunch are the independent variables, and the max score, reading score, and writing score are the dependent variables in the data set which was given to us. And the target variable here is the max score, because the problem statement which was provided for me from Hackveda was to predict the max score. So the max score here is the target variable. So this is the data set overview. And the tool which I've used here in order to predict my model, to develop my predictive model, is the Data IQ data set. So this data set which I have used in order to develop my predictive model, this software is generally being used by many data analysts in order to develop their model is based on different algorithms, and it is mostly used for the larger data set, which is not a very small amount of data set which can be done manually. So this data IQ software is used by many data analysts with using a large number of data. Choosing among different algorithms. So I was provided with a data set and I have identified what are all the independent variables, dependent variables, and my target variable. And now what I'm going to do is I'm going to deploy different algorithms in my model in order to check out which is best algorithm suited for my data set. Now, why there is a need for me to check with different algorithms? Why can't I just take one algorithm and just develop my model based on that result of that particular algorithm? Is, let us take an example. So let us consider that I'm going to plan a trip for me. So is it okay if I just predict my trip to Antarctica without any analyzation of the temperature? Is it suitable for my body? So Antarctica is not a place suitable for human. So its temperature is really very low, which makes the human to freeze. So how can I just plan my trip to Antarctica? So what I'll do is I'll just list out 2-3 places, and I'll analyze which weather is suitable for me, which expense is suitable for me for my planning budget, and based on all these analyzations I'll choose the best one for my plan event trip. So just based on that, and just as like that, we are going to deploy different algorithms, and then based on the result I'll be choosing one best algorithm for my data set. I hope this is very clear for the people. I've explained it with very examples and in a very basic term, in order it will be able to understand by even other people from other departments. So let me show my demo how I have deployed all these different algorithms in my data IQ data set. So this is my data IQ software. Here what I have done is, this is my flow which I have deployed here. So this is the student performance data set which was offered to me. So this data set, as said earlier, consists of all these features, that is the gender, race, parental level, lunch, test preparation course, math score, reading score, and the writing score. So these are all the features which was given to me, and this is the data set. So after applying this data set, what I'm doing is I'm preparing my data set. So I'm splitting my data set into two, that is the training ratio and the testing ratio. The training ratio will be 0.8 and my testing ratio will be 0.2. Now, why there is a training ratio and testing ratio? So in school, basically the teachers will be training the students, right? So they'll be just training the students with all the activities, with all the tests and all those things. But how will be they able to test the student whether he or she have taken the teachers' efforts and the learnings taught by the teachers? So they'll be giving a usual test, right, in order to check whether he or she is working good with that particular lesson or test which was taught by the teacher. In that very same way, we are going to train this data set with 80%, and we are going to test the same data set with 20%. So that is called the training ratio and the testing ratio. Now so first step, I have taken the data set, and then I have prepared the data set and I have separated it into two parts, that is the training ratio and the testing ratio. Then here I'm deploying it with the different algorithms. So random forest, ridge regression, lasso regression, and decision tree. So these are the 4 algorithms which I have deployed with this data set in order to check which R-score value is greater of the above 4 algorithms. So as a result, I have got 0.89, which is the highest, that is ridge regression has obtained the 0.89 value, which is the greatest R-square value among the given 4 square. So which indicates me that this is the best suited algorithm for my data set. Also, here is a graphical representation which tells me that which particular data set is very well suited for my. So here then I have just applied my metrics. So first what I've done, I've taken the data set, I have prepared it, and then I've deployed all the algorithms, and I've chosen the one best algorithm for my data set. And then now what I'm doing is I'm just assigning the metrics. So after deploying my one best, that is the ridge regression, what are all the metrics? So based on what are all the metrics, my ridge regression model has to be developed. That is, based on ridge regression, my prediction model has to be developed. So based on the EVS, MAE, MSE, and all the other scores, based on all the other scores, my model has to be developed. So after assigning my metrics, I am developing this model. So after deploying my ridge regression, here I have obtained my predicted score. So here 72 is my target variable for this particular candidate. 72 is my target variable. Okay. But the model has predicted as to be 65, where there is more or less a 7 value difference. Okay. So as the R score value was 0.89, which tells us that there will be a difference of 7 integers between the scores. So let's take this candidate, second candidate. Here she has scored a max value of 69, where the model has predicted it to be 78. So again, here is a difference. That is a 70% of difference in our mark that has been scored, which tells us there is a score of 70% difference in the model which was developed by me. And in the same way, there is a 70%, that is not 70%, a 77 integer value difference between my prediction and the max score value, which doesn't make that much great difference in his or her score value. So that's here I have developed my predicted, well-efficient predicted data set. So this is the performance metrics. It is very much needed in order to prove that my data set, that is my algorithm, is very much suited for my data set. So R square value is nothing but it is a value which ranges from 0 to 1, which indicates that if the value is closer to 1, it is very well suited to our data set. Or if the value is near to 0, it says that it is not well suitable for our model. So this is the R square, which plays a very important role in our data set. And this is the Pearson value. Pearson value scores from -1 to +1, which says us that +1 is the positive correlation which is given to us based on our data set, or if the value is -1, it gives us the negative correlation value, or if the value is 0, it says that there is no correlation. So this R square and Pearson is the most important factor where people will be analyzing it, whether their algorithm is very well suited for their data set or not. And these are all the other factors which has been assigned to us under the metrics. So these are the graphical representation of the metrics which was obtained in the previous slide which I've shown. So let me go through a quick recap of the model which I have developed. Firstly, I have taken the data set which was given to me, and then I am preparing my data set. That is, I'm analyzing the features, I'm analyzing what are all the target variable, independent variable, and the dependent variable, and I'm just splitting my data set into two, that is the training ratio and the testing ratio. And then here I'm deploying all my 4 algorithms, that is the decision tree, ridge regression, lasso regression, and the random forest. to predict this max score in order to see which algorithm is best suited for my data set. And then what I'm doing is I'm just checking out what are all the metrics I needed in order to develop this prediction model. After setting all these metrics, I've received my developed metric predictive model, which has a difference of 7 marks, and then followed by my metrics where all the scores has been given, proving that my algorithm which I have chosen is to be the best, and then the graphical representation of the metrics. So I hope it is a very simple explanation in order to make clear even to the other department people who are here, to make them understand my developed model. I hope you all are clear. Now let me get into my presentation. So as I've shown in my demo, these are all the algorithms which have used, and this is the R score value, different R score values. So as I've said, what is R score value? It is the score which decides the whether it's a well suited or well fitted model or not. So as I mentioned in this above four algorithms, ridge regression is the one which is very much closer to the value 1, which says that this ridge regression is very well best suited for my data set. So ridge regression with the score of 0.89 is proved to be the best algorithm for the provided data set, and I'm using it for developing my predictive model. So what is ridge regression basically? Ridge regression is an algorithm where it is used when there is more number of independent variables and when there is a lots of higher correlation values. So ridge regression, to explain it is in the simple terms, is it is an algorithm of the regression where it is used in the data set where there is a lot of independent variables and higher correlation values. So model evaluation, how I'll be evaluating my model is I'll be evaluating it based on my R score, Pearson score, and EVS score to test the best fitness value of my model which I have developed. So here I have developed my model in order to prove what are all the results which I have obtained. So even for future work, which I have not done here, which was not mentioned in my problem statement, even in the future work, we could even use the cloud platforms such as the AWS or Google Cloud to deploy the predictive model for the web applications. So this is just a future work or inference for the people who wanted to develop this model even to the next stage. They can just deploy it in the, they can try to deploy it in the cloud like AWS or Google Cloud to take it to the next stage of cloud platform. They can also integrate this. We can also integrate it with this software applications and APIs for even for different use cases, as I said, like for weather forecasting or for the stock market prediction value, stock market prediction, or the gold price prediction, or the color detection, brain tumor detection. Like this, we have different few use cases where we can deploy it. And these are all the other applications of the simple predictive model which I have deployed, which I have developed, where it can be deployed in different applications like brain tumor detection, color detection, petrol value detection, the gold price detection, the stock market detection, and it has a various lot of other scopes. So evaluation. Evaluation and validation of the model. So as I said earlier, I have evaluated this model based on the three factors, that is the R square value, the Pearson score value, and the EVS value. So this R square value, as I said, it is an value which ranges between 0 to 1, which says that the value nearer to 1 gives us that the value is best suited for the model, or the value which is nearer to 0 says that it is not much suitable. Pearson score, it is a correlation coefficient which is used to measure the strength of the correlation between the two variables. That is whether it is a negative correlation, positive correlation, or whether there is not a correlation at all. So 0 refers to there is no correlation at all. Positive value, that is 0 or 0.9, which is very much nearer to value 1, states as there is a positive correlation, and the value 2 is minus 1 states us that there is a negative correlation. And EVS. So EVS is nothing but it's an explained variance score. It measures the proportion to which a statistical model accounts for the variation in the data set. And then followed by the metrics, where this is the screenshot of the demo which I have shown you earlier, and that is here. And then the predictive model data set. So as I've shown, the 72 is the score which is to be predicted, and here 65 is the predicted value, and there is approximately a difference of 7, which doesn't make that much greater difference in the prediction value, and which proves it to be that the predicted model which I have developed is approximately better. So let's get into the summary of what are all the things I've discussed in my presentation throughout. That is, firstly, I've discussed what is predictive modeling, and I've given the example of weather forecast, which is a very good example for predictive modeling. Then the data set overview, I've gone through the entire data set, and I've given the what are all the features are there in the data set, and what are all the dependent and the independent variables and the target value. And then the algorithm selection, and I also given the reason why we have to select different algorithms in order to choose one best algorithm for my data model, and that is the ridge regression. And the metrics of the selected model outcome, that is the R-score, Pearson, and the EVS, are the three main metrics which I'm looking it into for the best values in order to prove that my model which I've developed is very much predictive. And I've also demonstrated the demo of how I deployed and developed my predictive model. And here is the references from where I have created my predictive modeling based on the student performance data set. That is the scikit-learn documentation. This is based on the supervised learning, the UCI machine learning repository, which was given based on the student performance data set, and then the using different regression models. So you can even go through these different links. You can just take a screenshot of it for your future reference. And I've also given the various applications where we can use this predictive modeling, and also the other further development in this project, where it can be also deployed in the cloud and various things. And here I've come to the end of my project presentation. If there is any question and answers, you can just unmute and ask me, or else you can email me at manushri.25it@lesa.ac.in. Thank you.
I hope you are done with your presentation, Manushri.
Yes, sir.
See, first of all, really well done. You talked about things like last time I had given you a review, and you did work on it. I can see that there are a lot of improvement. Like when I say lot of improvement, you have really made a lot of improvement this time. Your overall content was good, explanation was good, really well put together, I would say, easy to understand, as well as like some of the examples that you have taken, they were also good. But I think it can be more simplified, right? Because somewhere you talked about what is EVS, right? So, but you only had given the full form of the EVS and not really well explained. Okay, so somewhere you have done a really great job, but there are some little things that you still need to, like, take care of. So, but as you give more presentation, you will understand that. So, but for now, I can see that you have improved a lot, and that is a good thing. Your overall content, that is story as well as the hook, was also good. But again, it can be like, improved a little bit. But take time, give more presentation. What I would say is make a script of what you are going to say, practice it. After reading it 2 or 3 times, you will understand, like, what is lacking. You will understand it by yourself after writing it down. Okay, that will be better. Again, and also I think your PPT can be also improved. So let us say when you have a heading, you have an image, right? So also write some, like, input. Let us say when you are explaining an image, so you can make some small points. Let us say when you are explaining about the predicted data set, right? So whatever you are concluding, you can also add that in the PPT itself. So that, let us say, when I look at your PPT later on, okay, so that your PPT will make sense, right? When I look at a slide, it will only have predicted data set model and image. It doesn't really make sense, right? So that will be better. Second is that I can see that your communication skills have also improved a lot. So good job on that one. Okay?
Thank you, sir.
So yeah, so Hari Prasad, do you have a presentation? Hello, Hari Prasad. I don't think so. Okay. So do one thing. Kalyani Kumari, you can join Mr. Saurabh Singh's meeting, or it is either conducted by Akash Sharma. I have given the link in the chat. Okay. He will take your presentation right away. Because yesterday you couldn't give it, right? So just go on a meeting, let them know. They will take your presentation. Okay. So Kalyani, if you have understood, please join the link. I have given the link in the chat. Okay. So Sridevi, yes.
Hello, sir.
Tell me the name of your task.
Am I audible, sir?
Yes, yes, you are.
Yeah, my task was to develop a student performance predictor system.
Okay. It is self-predictive modeling, right?
Yes, sir, predictive model.
Okay. Okay. So Kalyani, please join the link that I have provided in the chat. Okay. They will take your presentation. I'm giving the link again. Join Mr. Saurabh Singh's meeting. Sridevi, now you can start.
Good evening, everyone. I'm Sridevi Satyamurthy. I'm a data engineer intern here at Hackveda. So my task was to create a predictive model based on the student performance predictor system. So I have developed it, and let's now have a quick presentation on it. So for the table of contents, I've listed down what we'll be discussing in this presentation. First, I'll take you all down through the introduction of what this predictive model is all about and what base research I have done here. And then I'll be explaining about the algorithm which I've used to develop this model. That is, I've used rich regression, and a supervised model has been developed here. So I'll be explaining about that. And then the data set which I've used to develop this model will be explained. And then the metric under which this analyzation was done will be explained. And then the result of my test and the model overview will be given, and a demo also will be given. And then the future work and conclusion about my system will be given. Yeah, let's now get into the presentation. So to start with, what is this prediction modeling all about? This is basically predicting something in order to gain knowledge from it. So, so let us consider an example of a teacher. So if a teacher wants to analyze his or her class, as a human, it is very much difficult for us, to predict each and every student, to analyze each and every student performance based on different categories. Suppose consider a student, consider any one of the student who is, weak in maths class. So as a teacher, I have to analyze his parental work. That is like whether his parents help him in his studies, and and then about whether he's going for a tuition center for improving his scores, or he's studying on his own, or is there any difficulty for him. I have to, take down each and every parameter which affects his study. So it will be very much difficult for me as a human to do it. So this predictive model, that is the student performance prediction model, will be very much useful for the schools and universities in order to, keep a track on the performance of the students and predict the results of the students in a forecast. So this will be the introduction to my system. Hope it's clear. And I've developed this system using the rich regression model, which comes under supervised learning technique of machine learning models. So why I have chosen it? Actually, Hackveda gave me a choice of, 3 algorithms: decision tree, random forest, and logistic regression. And why did I choose rich regression? So rich regression and lasso regression comes under logistic regression. So in my base research, I've created models, I've trained my data for all the three options which was given to me. That is for the decision tree, for random forest, and for logistic regression. On doing the base research, I got to know that logistic regression, that is the rich regression, L2 regression, gave me a more precise and accurate answer. So I went on to develop my model using that algorithm. As you can clearly see that, just a minute, I'll take the laser pointer. So yeah, it's visible here that the rich regression has got the highest score, highest R2 score, so that I can train my model using this regression, which gives me a more accurate prediction. So this is all about the introduction to my system. So let's see about the algorithm which I've used here. In order to go on with the algorithm, first let's see what supervised learning is all about. Under machine learning, we have 2 types of modeling. First one is supervised modeling, and the second one is unsupervised modeling. Under supervised modeling, we'll be, we'll be developing a model based on a predefined historical data set, and a labeled data set or examples will be given to that model, and the model will be developed based on that. And in unsupervised learning model, no such data set or prehistoric data will be given, that is labeled examples will not be given, and the machine itself will learn once it gets the inputs. So this is the difference between supervised learning and unsupervised learning. And I have used supervised learning model in order to develop my system. So because I was, given with the data set by Hackveda, using the data set, I can easily produce a supervised learning model. So that is the reason I've chosen supervised learning model here. And as I told you all, rich regression got the highest score when I did my base research. And what is this rich regression all about? Rich regression, also known as L2 regression, is a type of logistic regression. We all know what linear regression is. That is basic prediction using a linear type. So this basically, this type of rich regression comes as a branch out from linear regression, which is, a much more improvised version of linear regression, wherein overfitting of models can be prevented. That is, overfitting here means the model which I have used to develop my system will be overfitting for the model, that is overwhelming for the model in order to take in. So for these types of data set, rich regression is the best suit. So that is the reason I have chosen rich regression. So let's see what makes this system more special. This basically prevents overfitting, and this is a most regularized version of the system which can be done using the data set which is given, and hence this this model is more special than the other algorithm which is used. So let's now have the look at the data set overview. The data set which I was given was the student performance data set, and it has 1,000 records. That is the record of 1,000 individual students. And as we can see, there are 7 columns here. The first column is about the gender. That is the gender of the student, whether he or she is female, male, or other gender, and it will be mentioned in this column. And next one will be the race and ethnicity. That is which type of group that student belongs to. Then comes the parental level of education. That is, as I told you all, whether the parents help them or not also plays a major role in a student's life, in a student's performance. So the parental level of education is also taken into account here. And then the lunch. Here the lunch. Here why they have taken the lunch here? They have taken this as a variable because this can reduce a student's stress level, so that whether he or she gets her lunch beforehand or they have to prepare for it. So yeah, that is the reason they have taken this variable also. Then the test preparation course, of course, preparation going for a tuition makes a much difference in the score of a student. As a task, I was given to predict the math score. So here we have three different scores: math score, reading score, and writing score. But I was given as a task to predict the math score of that specific student. So on considering that, we need not see about the reading score and the writing score here. So we'll be predicting this math score. So this will be our dependent variable, and all these columns, the first 5 columns, will be the independent variables here. Hope the data set is clear now. So on what metrics I have analyzed my model? So the first one which I have taken is the R-squared score. What is this R-squared score? This is basically, the measurement level which ranges between 0 to 1, wherein the accuracy of my model will be tested. That is how well my model can predict one value will be tested using this metric. So the value of my test results for the system which I have done will be given later. So first, let's see what are all the parameters under which my model can be tested and evaluated. As I told you all, R-squared score is a measure which basically finds the difference, that is the variance between each and every variable. As I told you all, the final column, that is the predicted column, the math score, will be a dependent variable, and all the first 5 columns will be my independent variables, and the variance between these columns will be predicted, and then average of it will be taken as R square score. So that's all about the first metric. And next comes the root mean squared error. What is this all about? This is taking the difference between the predicted value and the actual value. So using my model, we can predict the math score of a student, and that predicted value will be subtracted. That is the difference between the predicted value and the actual value will be found, and then the mean of it will be taken. The mean of the square of these errors will be taken, and the root of it will be given as a root mean square error. So this will make me understand how far the error rate is. So this is all about the second metric which I've chosen to analyze my model. And next comes the accuracy. The accuracy of a prediction model is very much important. So the importance will be given more to R-square score and the accuracy rate. So this accuracy will be classified under 2 different categories. First, we'll be seeing about the Pearson coefficient, and then about the EVS score. So what is this accuracy all about? This is basically, how accurate my model is. The word can simply tell us the meaning, how accurate my model can be. So these are the 3 basic parameters which I've chosen in order to analyze my model. Okay, let's now take a look at the test results. According to the data, I've got an accuracy of about 85%, which is actually a greater percentage. Which makes my data set, that is my prediction, to be more accurate. So next comes the auto score. As I told you all, auto score is more important, way more important than any other metrics. My auto score is around 0.87, which makes a good fit. So I can proceed with this algorithm. Then coming to the Pearson coefficient. So this Pearson coefficient is again basically an accuracy parameter, wherein my models wherein my model's correlation coefficient will be analyzed. What is this correlation? So correlation, from the word we can get the meaning as a correlation. We'll be relating different variables onto each other, which again comes under the accuracy topic. So my Pearson coefficient, which I have got for my model is 0.93, which again speaks about the high accuracy of my model. So these are the test results. So before looking at the overview of the model, let me take you all to the demo. So the software which I have used to develop my model is the Dataiku DSS, which is Dataiku Data Science Studio. This is the most ordered software which data scientists, data analysts, and data engineers use. So as a data engineer intern, this will be more useful for me. So I have chosen this software. So yeah, this is the flow of my model. As I told you, first I did the base research. The base research will be basically what are all the algorithms which can be applied to my model. I'll be applying it, and then I'll be seeing which model gives me a more accurate, more precise answer. So let's now see the base research in detail. Yeah, before it loads down, I want to make a point that this basic the rich regression is chosen as the first one based on the R2 score here. As we can see, the R2 score is much greater for rich regression. So if I can change my parameter, that is the metric which I can choose for my model. Since this is a performance predictor model, which is a discrete model, I have chosen R2 score. We can also see the EVA score for my model, which again tells me that rich regression, L2 regression is the best fit for it. I can change it to correlation also. So for correlation, we can see that both L2 and L1, both of these get the same value, 0.434 as the value. So yeah, based on the R score, I have chosen that L2 regression, rich regression, will be more suitable for my modeling. Let's see about the parameters which I've used for to develop the rich regression model. Feature importance. Okay, as you can see, the gender of a student is basically more contributing towards my prediction here, but the race and ethnicity and parental level education is almost equal. It almost equally affects my prediction. The percentage here gives me how much this specific variable affects my prediction. So these are the four main variables which affect my prediction here. So this is all about the base research which I have done. Let's now get into the actual model. So this is the actual model which I have developed. So this model is developed using the regression type, that is the rich regression. Yeah, this is a rich regression model. So we can see the writing score, gender, reading score, lunch, test preparation score, race and ethnicity. All these features are given most important values. So in the first one, in the previous base research, I told you all only four things were taken into account, which basically will reduce the accuracy and prediction rate of my model. So I then moved on to use all the 7 parameters, which then made my auto score will be to be more greater than the first one, which in which I did the base research. Let's now see the predicted performance of the students. That is the predicted data set. So yeah, this is the predicted data set. As you can see, this math score is predicted here as prediction. So this is the actual score and this is the predicted value. We can see that 72 is the 72 is the actual score of the student, and the prediction value is 65, which is more or less the same. So the error rate can be noted here, which is -6, which is, almost lesser than 10, which makes my model more fit. So we can actually see the error values for comparison. We can see the error value is -6, 9, -5, 5, which basically tells me that my error is between plus or minus 10, which basically makes my prediction more accurate. Let's now have a look at the metrics. So under metrics, the main one which we have to see is the EVS. This is basically again a comparison score here, which is 0.86, which is more greater than the previous one which we got, which was 0.13. It was very less, and this is actually very great here. So again, the R2 score is 0.869, which is almost 0.9 here, which again is closer to 1 and makes my model more accurate. And then coming to the Pearson coefficient, it is 0.933, which is again a large, which is again a great score for my model. So yeah, this is the overview of my model. Hope the demo is clear. Let's now get into the presentation. So this is the overview of my model. So this will be more helpful for teachers in order to analyze the students. So what is the application of this model, and what is the reason behind developing these types of models? And we'll be seeing about the limitations also. So first we'll see about the applications. So this model, this system can be, as I said before, this can be used to analyze a student's performance in order to improve them. So basically, consider a situation where whereas a group of students are getting into the 10th standard, and their initial score, their first test score is analyzed. So so taking into account the first test score, I can actually predict what type of score they can get in their final exams. So on predicting that, I can concentrate more on the student who have less who has the more who has scored less score in my prediction. Yeah, that is all about the applications here. And then coming to the limitations, as I told you all, limitations. The main limitation here is that the student behavior can change. So as a student, I'll be more lethargic in my previous phase of my 10th standard, and then I can catch up with my work. So this is the main limitation, that the student behavior can change with time, and the system is basically trained with a prehistoric model. So that is the only limitation we can see here. Let's now see about the future work. So what future work which can be applied for this system? We can actually overcome that limitation which I told, the student behavior cannot be taken into account, by training the model with more and more new data. That is, once the test 2 gets over, we can again train the model with the test 2 data, so that we can get an average of both test 1 and test 2 and see whether the student has improvised or not. So this will be a future work in order to make a more relevant data model. So that's all about my student performance prediction system. So to conclude with, we have seen about what based research is all about, what predictive modeling is all about, and how we have to do base research before getting started with a data science project or data engineer project. And then we saw about the different metrics which has to be analyzed in order to create a model. And then we saw about the student performance predictor system which I created, and based on the parameters on which it was created, and then the test results were seen and the model overview was seen. This is all about the conclusion of my predictor system. For reference, I've used YouTube as the main source. So this will be the link for the YouTube video which I have referred. If anyone wants, can take it down. Yeah, so I'm done with my presentation. Thank you for patiently listening. If you have any queries, you can ask them.
Okay, so I hope your presentation is done.
Yes, sir.
Okay. See, it was a good presentation. I would say the content on your presentation, are not like, up to the par, but your explanation was really awesome. Okay. You have improved a lot from last time. I can see that. But as you give more presentation, you will improve more. Okay. So basically your conclusion part, I think, can be improved. See, in previous presentation, she have like, included the numbers also. So what accuracy you are getting, various articles, right? So in conclusion part, you are also like, required to add those information, because you have done a task and then you got some result, right? So that is why we have the conclusion slide, where you can add that information and then you can basically go through, let us say, or summarize how you got there. Okay, that will be much more better, I would say. Okay, so just work on that part. Overall, I would say that the improvements that you have made are visible. Okay, and they are positive improvements. So keep up with this good one. And again, I would like to see more improvements towards the ending and conclusion part. Okay.
Okay, sir. Thank you, sir.
Yeah, thank you, Sridevi. So I think we are done. Manushri, you have any more presentation? Or we can conclude here for the day, because I believe you are the only people in the remaining. So if we are done, then I think we can conclude here for the day. Thank you for joining. Okay, yeah. So thank you for joining. We'll conclude here.